Microsoft's Excel is an incredibly powerful tool for producing high-quality plots for an arrangement of scientific or scholarly applications. In this video, common methodologies for plotting in Excel will be explored, but keep in mind that anything that can be done in this program can also be accomplished by hand. Additionally, this demonstration will focus on the steps required to construct a plot in the Windows version of Excel. And while the Mac version of the program is similar, it is by no means completely identical. Once we have opened Excel, the first step is to enter the data that we want to plot in the relevant cells available in the program. To make graphing easier, it is best to enter the data in columns, with the first column representing the independent x variable of your plot, and the second column representing the dependent y variable. We will quickly enter some random linear data for this simple demonstration, but to make this a little more meaningful, we will pretend that this data represents some velocity measurement taken at a regular time interval. This means that the x variable will represent time and the y variable will represent velocity. To create an initial plot, once we have navigated to the Insert tab, we will highlight the two columns of data, then select the down arrow for the scatter plot option and select a simple scatter plot. We will eventually add a trend line, but when displaying our data, we want to start by showing every data point, then indicate a possible data trend. This is very different from a line plot that will simply play connect the dots with our data points. Before moving forward, it is important to inspect the plot of your data points to make sure that they are orientated properly. Excel is not flawless, and situations could arise where your data was plotted on the wrong axis, like this. Especially for this example, the difference is very subtle. But by carefully inspecting the magnitude of each axis, it should become apparent if the data is incorrectly orientated. The data plot may be reorientated by selecting the last option on the menu that appears when you click on the previously generated plot. Then, in the pop-out menu, at the bottom right-hand corner, click the Select Data option. This should open up another dialog window, where there should be one series available in the left option box. Select this series, then select the Data option, which should open yet another window. In this window, you will have the option to either type out the code sequence for the cells that contain your data, or, if you are not familiar with the Excel code formatting, simply select the icon that looks like an up arrow, then select the relevant cells in the Excel environment. Hitting Enter or clicking the button that looks like a down arrow will return you to the previous menu, where you can select the data for the other axis. Once the correct data is selected for each axis, simply click both OK buttons to exit back to the Excel workspace. Next, click on the data plot and select the first option in the side menu bar, which looks like a plus sign. In this menu, we can add a few more things that the plot needs. The first thing to add will be the axis titles. Then at the bottom of the menu, check the box next to Trendline option. Clicking on the side arrow next to this option will display another menu. At the bottom of this menu, select More options. The sidebar that will appear offers a large selection of options for the trend line. If we wanted, we could change the equation of the line to something other than linear. But for this example, we are more concerned with the last option of this menu, which include displaying the equation and the r-square valued. The equation describes the linear trend line that was applied to our example data. In this case, because this was a velocity versus time graph, the slope of this best fit line would represent the average acceleration. The r-squared value is the correlation coefficient, which indicates how well the data adheres to the best fit line. In this case, we already knew our data was linear, so the r-squared value is 1, meaning that there is perfect linear correlation. Exiting from this menu, we have only to finish filling out the names of the axes and their units, along with adding a title to the plot before the plot is complete. This plot can now be directly printed or copied into another document for use in reports or other projects.